So today we start a new series of the ds-incubator, and it is going to be about how to explore your data with the tidyverse. As usual, there is now a repository associated with the series. It is called ds.tidy EDA for exploratory data analysis. And well, the goal is, as I just said, to know how to explore your data. The focus will be on the more analytical side of things, not so much on the tooling, but tools, we need them to actually get to get the answers from the data that we want to answer. And the idea is that at the end of this series, we will have knowledge about how to explore the variation, for example, within one variable in your data set. And we're going to be doing that with ggplot2 in a visual way and with dplyr in an analytical way. Also, how to, for example, explore unusual values and missing values. And then, beyond one single variable, you may have questions about, well, how two different variables relate to each other. So we're going to be exploring also covariation between two variables. And then that, variables come in different flavors. So some variables are maybe continuous, some variables are categorical. So how do we, explore covariation between, say, two categorical variables or one categorical and one continuous variable? So those are all very analytical and very general questions that have very little to do with the tooling. So hopefully, after this series, you will have kind of an expanded view and more general view of what it means to do an exploration of your data, and also we're going to be talking about patterns. So some variables have a pattern, and we might be able to extract that pattern with a model and then see what remains to see if the pattern can be explained by a model or not. So what's important about exploratory data analysis is that if you are in the world of research, so if you are researching yourself, then the exploratory data analysis will spark questions in your head that you didn't have before you entered that process. So it's a very iterative process, and something is the process itself is like a tool for thinking, for refining your thinking. But also, even if you're not if you're not the one creating the research questions, and those questions are kind of delivered to you, still exploratory data analysis is useful. For example, if you manage data, because you will always need to understand what's the quality of your data. So exploratory data analysis will give you a systematic approach to exploring the quality of your data to see if what you have there makes sense or not. The syllabus that I'm going to be working with basically is walking through the chapter 7 of the book R for Data Science, and that book chapter has some prerequisites. So that, as I say, it's chapter 7, it's not chapter 1. So by the time you hit chapter 7 in that book, you already should have some basic understanding of like a workflow. You should already have your RStudio set up correctly. You should know at least the minimum of dplyr and ggplot, so that then you can use those tools to understand exploration of your data, and not so much your focus shouldn't be on the tools themselves, but should be on the analysis side. But this meetup series does not assume any of those prerequisites. So my goal today is to start talking about those prerequisites, so that by the time we actually hit chapter 7 in that book, we are all kind of on the same page. Does anyone want to make any comment here up to this point? Okay, good. So what I thought then, good.
We're not supposed to be seeing your screen right now.
Oh, shoot. Okay. Thank you. Oh, yeah. One of the many things I usually forget. Entire screen. Yeah, I wasn't intending to give you the show on my face. So maybe what I have to highlight here is that this is the name of the repo, ds.tidyEDA for tidyverse or exploratory data analysis with the tidyverse, tidy exploratory data analysis. And we are going to be here today talking about the prerequisites. And as I was basically developing the syllabus for today, I realized that a lot of what I would love all of us to be on the same page of has to do with what I would call a defensive workflow. So, what do all the things that are around your analysis and not so much your analysis. So I think it's good to get all those things out of the way, as early as possible, so that then we can actually talk about exploring your data. But all those things around your analysis can create so much friction that if you are not on the same page there, very likely you will have a very frustrating experience. And this is the kinds of things that are very rarely taught when you talk about data science or when you're taught about R. All these things are related to workflow that sometimes don't even make it to your script itself. It's things about setup and philosophies about how you should write files and path and things like that. So with this, I also envisioned the following structure for the series. So today, I think that what we're going to be covering today is so important that even if you never join any other meetup in the series, the contents of today, and maybe if we overflow a little bit of next meetup, will be useful for themselves, because at least you will know what a good defensive workflow looks like. So that means that you would have a good stopping point when we finish covering the prerequisites for the series. Then we're gonna jump into the actual exploratory data analysis, and then if you want to really learn about that, you should stick to the end of the series. But yeah, so first exit point for this series is whenever we finish covering the prerequisites. I don't think it's gonna happen today because it's quite a bit and it's quite important. So I want to make sure we have time for questions and comments about that. Okay, so the idea is to overview the elements of a defensive workflow. And also, I'm not going to be expanding a lot in each of them because it would take a long time, but I do have very good resources to learn more about that to recommend you. So if any of that doesn't quite make sense and sounds like arbitrary, okay, why Mauro is telling me to do this or that, I won't be able to explain now. I don't have that space, but I will give you links for you to kind of educate yourself more and then see if you agree with the practices that I'm going to be recommending here. Hopefully, I'm going to be also introducing R Markdown documents, which is a great way to intermingle code and prose. Also, I'm going to be talking about what is a data science workflow in general, the different parts of doing data science, and what tools I'm going to be talking, or we are going to be using in this series to basically tackle each of those steps in the data science workflow. And then the two main tools, we need to zoom into them a little bit, which are a tool to create graphs, which is ggplot, and there is a little template that you can reuse in all your plots. We're going to be talking about that. And finally, a couple of verbs in dplyr. So dplyr is an R package, basically a collection of functions that are available to you through that package. There is a ton of function in that package, but there are very few that are used in this series. So hopefully I will give you a little bit of a flavor for what they are and how you can use them, and basically how you can compose many simple verbs to create a more complex data analysis pipeline. Okay, let's jump now. So that was the syllabus. Let's jump now to the contents of today's meetup itself. So for you to know, as I said before, there is a repository, 2 Degrees Investing, called ds-incubator that contains all the materials, and each meetup has a folder. So the folder of today is 01_prerequisites. So in that folder, you'll see a README MD file, which automatically shows here on your web browser. So this is what I'm going to be talking starting now. Before we actually get there, anyone wants to make any comment or question right now? Okay. The idea of defensive workflow is what we're going to be talking right now. The first thing I want to mention is that we're going to be using our studio. That's what I assume. You are welcome to use any other IDE, any other interactive graphical user interface, but I'm going to be using our studio. So I'm going to pop up our studio. And let me close this project just to try see more or less what you might see. You might see something like this. So R has started, and let's make this a little bigger. There is a bunch of panels, one for R, and here I could create a new file. This is where the source code will go. So first thing, we're going to be using an IDE. Using an IDE is very important because it helps you work very efficiently to do things that if you work in just plain text in a text file and not use an IDE, you will experience a lot of friction. Now, RStudio by default doesn't come with the greatest defaults because it inherits defaults that come from R, so there is only so much that RStudio can do to provide you with a workflow that is ready for success without being in conflict with R. So R has some defaults that we need to kind of overwrite to create defensive workflow, basically. And the very first idea is the one written here, that you should start from a blank slate every time that you restart R. Unfortunately, R by default will tend to save your working environment, your working space, and will try to reload it when you restart your R session, and that is a pretty bad idea. It causes a lot of trouble. Makes your research not so reproducible in many times. So the very first thing that we need to do is make sure that you start from a blank slate every time you start R. And there's a couple of ways to do that. So I'm gonna go to RStudio and show you the few ways that I like doing it. So this is the kind of thing that you do only once and then it's set forever. So in RStudio, a recent version of RStudio includes what's called the commands navigation bar or the commands panel, which you can access with Shift, Control, and P. This allows you to start typing keywords and access commands that would otherwise require a lot of clicking. So this is how I like doing that. So now, for example, here I type the words that you will find in that navigation bar. So if you start typing save workspace there, save. Yeah.
I was gonna point out that we couldn't see your RStudio, but now we do.
You can now. Oh, that's weird. Huh. Okay, so probably because I switched windows. Okay, cool. Thanks. So if you start typing save workspace, you see already that the second one here is save workspace on quick, which exactly matches this, the phrase that I wrote here. So you have to make sure that it says never. Another way to access this thing would be to go to Tools, Global Options, and in the basic section, the one that you get right away, here you need to ensure that where it says save workspace, say never. The default, I think, is always or ask, but you have to change that to never. The other thing is that this box should be unchecked. So if you go to what I wrote here, load workspace on start, that you can use the navigation panel with Shift Control P if you want and paste that. That will give you this. It should be to off. Right, and yet another way, if there is a package called use this, so the use this has a function called use blank slate, and you can decide if you want to set that type of defensive workflow for your entire project, or for a single project or for your entire user, so for every single project that you use. I think that if you say nothing, the function will somehow prompt you to, will tell you what you should do. It didn't do it here now because I think that I'm already using a blank slate. So once you do that, you have to get into the habit of restarting your R session a lot. There is a keyboard shortcut for that, but also you can find it here in session, and also here you go, session restart R. One good way to get there is also with the panel again. Shift Control P is the only keyboard shortcut that you really need to know. You can start now, restart R, and there you will have, if you just hit enter there, it will restart your R session. So the combination of that setup that I have just explained, plus restarting your R session, sets your project in a way that every single time that you run your script, nothing around your script is going to contaminate your results, meaning that anyone else could reproduce what you are delivering in exactly the same way. So if you have some object that is saving your computer only, and that influences the result, then someone else trying to reproduce that result that does not have that object saving their computers, then they will have a different result, or they may just not even be able to run it. So that's why it is so important. So that's the very first thing. We covered this part here. The other idea is the idea of project-oriented workflows. So notice that each of those headings here are highlighted as hyperlinks. So you can click there and read more about them. There is a whole book chapter talking about that idea. So I'm not gonna explain it in detail. You can read on your own, but I'm going to tell you how you can actually do it. So the idea is, before I show you that I am here in our studio, but I'm not using any particular project. How do you know that? Because where it says project, it says there is none, right? I'm not here using any particular project. So if I wanted to create an RStudio project to follow this idea of using project-oriented workflows, then I need to either create a new project or open an existing project, or maybe navigate to a recent project. So that is fairly straightforward. In File, you can always go and create a new project, maybe an existing directory if you have one that the folder exists but is not yet a project, or you can create a new directory. I'm going to create a new project, and I always use, so this is a very important concept as well, to know where your projects go. So I always save my RStudio projects in a specific file, in a specific folder that I call Git, because usually every project that I work with R also is being tracked by a version control system called Git. So that's where I could do, demo is the name of my project. It's going to go inside the Git directory. And when I have this box checked, but this is not the goal of this meetup, so you may ignore it for now. So that what we'll do is we'll create that project, close the project that, or the no project that I was before, and restart a new one. And now notice that there is a new folder inside the directory Git that I defined, that was, the parent of the project. And then there's a bunch of files here that basically just tell RStudio what to do. You don't need to worry about them for now. You might also not see some of them because you can hide them if you want. Some of them could disappear from your eyeballs if you click that hide hidden files check-in thing. Okay, I'm going to go back, and I acknowledge that CJ is about to kick me out. So let me see. Okay, to cover the tip of having a dedicated folder for your projects. In my case, I use a folder called Git, which is the parent to all of my RStudio and, at the same time, Git projects. Also, recommend logging recent projects. If you do have recent projects already, then there is one quick way to get to them. I press Alt F to pop up this menu, and then if I press J, that would go to recent projects. So, for example, a project that I have been working recently is the one that hosts the code for this meetup. So I can click there. So that's a very quick way to navigate to recent projects. And then a final very good way is to use a dedicated application like Alfred or Albert in my case. So that application looks something like this. I press Shift and Tab, and here I can start typing ds whatever, and then I will get all the projects that match that string. It's a very easy way to launch an existing project. Okay, this is a potential stopping point. I would probably like to cover a little bit more, but right now I want to acknowledge that what we've seen is a lot of content, and I think it's very important, more than to pack a lot of content today, I think it's important to understand what we cover, and to be sure that you can do it yourself. And if you have questions, please bring them up now. So yeah, I'm going to shut up and ask you if you have questions or comments. Okay, then are we okay if I move on a little bit to at least cover all the content of defensive workflow? I think we're pretty close to to the end? Anne said yes. Okay, cool. Probably by the end, if we have a few minutes, maybe one discussion that would be interesting to have, if for those who have worked with R for some time already and then remember what was life before and after adopting a defensive workflow, if I can bring some anecdote about how much more efficiently they started working once they started embracing some of these ideas. So I keep that for you to think what anecdote you would like to share. So go back to the contents of today's meetup. Another idea that is very important and also covering the same kind of book that I'm using to talk about defensive workflow, you can see more of that here in this chapter, is the idea of using safe paths. So I know that this might look a little weird, but once you define an RStudio project, then there are some tools that help you create paths that are relative to that project. Particularly important is that the paths that you include in your script are paths that are nested inside that project. It doesn't matter how deep inside, but they have to be inside for these tools to work as they are intended to work. That way, when you deliver a project to someone, for example, via GitHub, then that someone will get everything that your scripts need for them to run, right? So one tool that does that is the package here. The package here has a function called here. So if you haven't seen this syntax before, saying here column is basically calling the package here and then using the function here from that package. So this, I know it's a very weird way to creating a path, but it just works. It really works really well in anything that is inside your project folder once you created your project. So remember, a precondition for this to work is that you have to follow this idea of project-oriented workflows. So in this case, I'm doing something very simple. Notice how the path that I created only knows about anything that is inside my project. Data is a folder and greeting.txt is a file. So this bit only. Everything before that, it is very important that does not make it to my hard-coded script. Why? Because this path contains my name, for example. And if you want to run this script in your computer won't have a valid path that has my name in it. So everything that I highlighted here in this text should not be hard-coded in any script that you want to share with the world. And even if it's with yourself, you shouldn't do that, because maybe you change your computer and then you move this script from one computer to the other, and then that computer may have a different structure of the file system, and that means that this script will break, will not work. So here abstracts that prefix so that you don't have to hard code it in your script. What could be a bad idea could be to do something like this that may sound like more familiar. Okay, I'm gonna just type something that goes like C users Mauro blah 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 all the way to data greeting txt. But that's very bad, because someone else won't be able to reproduce that. I mean, the chances that they will are 0%, right? So, and if they need to change that, they need to change the code to reproduce your analysis. So it's not reproducible as is. Another really bad thing that is happening in this path here is that it has a name that is very difficult to work with across computers of different platforms. So Windows may be okay with something like this, fragile space path, but my Ubuntu system doesn't like anything like that, and it could break. Probably this path I won't be able to read it. So in terms of how to write file names, Jenny Bryan wrote a really nice presentation that you're welcome to see. This link points specifically to the slide that I'm showing you here. If there's 2 links away. But the whole thing is really, really good. So I recommend you to have a quick look. But basically, is I don't do things like the ones are here, the no's, and these are the yes. So start, for example, the file with your date, starting first with the year, then with the month, then with the day, underscore, and then something like abstract -for-sla docx. That has no spaces. It will work in every system. This type of format of the date will be sorted very nicely by time, and the month in the middle, helps doing that, as opposed to putting the month anywhere else in the structure of this way of writing dates. And here is a bunch of other examples. I think it's pretty clear why things here might not be so good and why these ones are better options. But if you need to learn more, then do go ahead and read Jenny Bryan's presentation. Okay, so the next thing would be to talk about the data science workflow itself, but because this is kind of changing gears, maybe right now is a good point to stop and maybe talk for a couple of minutes about just purely workflow related things. Let's see if I can go back to your faces here. Yeah, any question before prompting for anecdotes and comments? Go ahead.
I think CJ was before me. CJ, if you have a question.
Go ahead, and I have a...
Okay, but mine is very, very basic. So Mauro, could you just one more time explain what is a project-oriented workflow? What does that mean?
Mm-hmm, yes. So a project-oriented workflow means that you have created an RStudio project to make, to simplify things. That instead of working, basically means that if you are working in RStudio, what you see here in the top right has a name, as opposed to have something like this. Let me show you. So you may be working in RStudio, but if what you see in the top right says project none, you are not using a project-oriented workflow. What you need to do is to decide which folder you want your analysis to live in, and then create an RStudio project, go into File, New Project. If you have the folder already, navigate using existing directory, and then you find that directory in your computer, and that will create a project that will close this and restart your project where you have just created it. To give a little bit more, like a hint for more nuances, there are other ways to define a project. Specifically, if you use the here package, here will be aware of what a Git project is, for example. Or you can, if there is nothing like a .git directory, then the here package will drop a file called .here, and that will define a project. But those are kind of weird edge cases, so I don't want to distract your attention to them. Instead, I would simplify the world for now. A project-oriented workflow is that you have if you have a named project in the top right corner of RStudio.
I'm doing this because it's better to replicate and stuff, yeah?
Exactly, yes. Once you have a project, you can share the whole thing, the whole folder with all the files inside with someone else. You can email the whole folder if you zip it, or you can push it to GitHub, for example, so that someone else downloads that thing. And then everything that you need to search inside that directory, for example, if you need a data set, you will write somehow a path to that data set. As I showed before in the example, you will say something like, read_CSV, data/mydata.csv, right? So that path is relative to the root of the project that you created. And that path that I just kind of spelled out does not include anything like Z, column, Mauro, whatever. That is great because that means that if I create a project, I can send it to you, and because it doesn't contain my name, so nowhere in the script there is any reference whatsoever of who is the person running the script, meaning that it's fully reproducible in anyone's computer.
Nice. Okay, cool. Got it.
CJ, I think you're next.
Yeah, so I was going to reflect on this, but now it kind of feels like I'm beating a dead horse. But yeah, for me, this project-oriented workflow was a major change in how I did work with R. I started using R more than 10 years ago, before RStudio existed. And even the first versions of RStudio still did not have this concept of project-oriented project. So in that world that we lived in back then, we we still, of course, kept sort of projects in the subdirectory or something like this, but everyone had their own ways of trying to figure out how to refer to files that were in that directory. Some people, what they always do is they start off by using the set working directory to what that project folder is. Some people wrote fancy kind of things that would try to determine what was the directory that this script that you're running is in or was opened from, and that's a lot like what this package here is doing. And then RStudio came with this concept of the RStudio project, which technically the total magic that's happening is when you open an RStudio project file, it sets the working directory to the directory that lives in. It's really that simple. And I was a little skeptical of this when it began, because I'm like, oh, it's doing some magic. If you open this not in RStudio and in the RGUI or some other thing, then you don't get that. Or if you open it on the server, so I was a bit hesitant, skeptical with it at first. But once you get into that, it just solves all of these problems in one fell swoop, and it's so much better. And then, honestly, you don't even really need this here package, because RStudio does this one simple thing. It sets your working directory to the root of your project. And once you do that, you can give yourself the rule, never, never, never set the working directory. Unless you really, really know a specific reason why you're doing that, just don't ever do it. Don't ever set the working directory. And you're fine. And everything is just relative to where your project begins. And it's so much easier. And one other comment on this, on building paths, because Mara mentioned the paths with spaces in it, and there's also different delimiters between directories. I highly suggest using the file.path function to build paths programmatically rather than using paste zero or writing out strings and including path delimiters in them, because honestly, it's a lot safer to just use file.path.
Thanks, CJ. Maybe the last comment I want to make is that all of this meetup today is a super compact version of what I envision as a whole series that is walking through the book by Jenny Bryan and Jim Hester that is called What They Forgot to Teach You About R. So you will notice that every chapter 1, 2, 3, and 4, are the things that we've been talking today. So I compacted all of that in 25 minutes, and there is a lot there, including the whole history that CJ just explained very eloquently, as Jenny Ryan explains how she used to work before RStudio, before our projects, and how she came up with her own way of setting working directories and doing all of that. So if you're interested in understanding more the context, other than just embracing this as okay, this is what I need to do, I just do it. And if you need to understand why, Jenny Ryan will explain it very eloquently there too. Okay, it's 5 minutes past the hour where we should have stopped. So I'm gonna go back to your faces and ask one more time if there is any kind of burning question here or comment. Okay, then I thank you all. I hope that this recording will be material that we can use for onboarding new colleagues as well. So I think that in a way it's kind of good that we didn't get to cover the exploratory data science part of thing. We'll leave that for the next meetup, but at this point, the material that we have covered now is the minimum that you should know if you join 2 degrees and need to work effectively with everyone else, because this is going to be our expectation. Thank you very much. See you next time.